In the endless darkness of the universe, some worlds defy every limit of imagination. Rocky planets orbiting dim red dwarfs, giant gas planets wandering alone, or water worlds with bottomless oceans. Yet none of these oddities compares to the blazing nightmare known as KELT-9b. Daytime temperatures on KELT-9b soar above 4,300 degrees Celsius. To put that into perspective, that's hotter than the surface of most K-type and M-type stars, the most common stars in our galaxy. It reaches nearly 75% of the Sun's surface temperature and is hundreds of times hotter than Earth's lava. Here, hot, as we know it, becomes meaningless. If, by some impossible means, you were thrown onto KELT-9b's dayside, you wouldn't just die, you would vaporize instantly. Every molecule in your body, every metal atom in your blood would be ripped apart by the monstrous heat and swept into the burning atmosphere. Welcome to the hellscape that is KELT-9b. Now, let's unravel its most insane mysteries. The journey to discovering KELT-9b didn't start with a giant telescope, but with a bold idea and a network of surprisingly small ones. The project's name says it all. KELT, short for Kilodegree Extremely Little Telescope. Proof that in science, size isn't everything. Persistence and smart strategy matter far more. KELT had a clear mission: hunting for hot Jupiters. These are gas giants with masses equal to or greater than Jupiter, but orbiting dangerously close to their stars. Imagine Jupiter pulled inward until it orbits even closer to the Sun than Mercury. That's a hot Jupiter. The method KELT used is called the transit method. In simple terms, if you stare at a lamp and a fly passes in front of it, the light dims slightly. Astronomers do the same on a cosmic scale, monitoring the brightness of millions of stars. If a star periodically dips in brightness, it could mean a planet is passing in front of it. KELT used two robotic telescopes, one in Arizona and one in South Africa. While they don't have the high resolution of Hubble, they have an incredibly wide field of view, allowing them to scan hundreds of thousands of stars at once. They're like tireless guards, constantly watching for the tiny blinks of distant stars. In 2016, among a massive sea of data, scientists detected a very unusual signal from a star named HD 195689, about 670 light-years away. The dip in brightness was clear, consistent, and extremely strange. It was deeper than normal, suggesting the object passing in front of it was enormous. And its orbital cycle was absurdly short, only about 1.5 Earth days. This immediately caught attention. A planet that big, orbiting that fast? The team knew they had found something extraordinary. Follow-up observations with more powerful telescopes confirmed their suspicions. This wasn't just another hot Jupiter. It was a monster. They named it KELT-9b. When the first data was published, the astronomy community was stunned. The numbers were astonishing. A gas giant nearly 3 times the mass of Jupiter, but almost twice the size. That means its density is extremely low, half that of Jupiter. The star's brutal radiation has puffed up its atmosphere like a gigantic balloon. But the most shocking number was the temperature. Over 4,300 degrees Celsius, instantly earning KELT-9b the title of the hottest planet ever discovered. Professor Scott Gowdy, one of the lead researchers, famously said, "This is the hottest gas giant planet discovered so far." This discovery opened a new chapter in the study of extreme worlds. Can a planet even survive such hellish conditions? what happens to matter at those temperatures? To answer that, we need to examine the source of all this brutality: the star KELT 9.
To understand why KELT 9b is a hellworld, we must talk about the tyrant that forged it, the star KELT 9. In the universe, the relationship between a star and its planets defines everything. And in this case, KELT 9b drew the worst possible card. KELT 9 is nothing like our gentle sun. It is a B/A type star, one of the hottest and brightest categories of stars in existence. While the sun is a modest yellow dwarf, KELT 9 is a massive white-blue behemoth. Just look at the numbers. KELT 9 is more than twice the mass and size of the sun. But the biggest difference is surface temperature. The sun's surface is about 5,500 degrees Celsius. KELT 9's surface is nearly double, around 10,000 degrees Celsius. Its light is brutally intense, emitting powerful ultraviolet radiation capable of literally vaporizing planets. But it gets worse. KELT 9 spins incredibly fast. The sun takes about 27 days to rotate once. KELT 9 does it in just 16 hours. This breakneck speed causes a dramatic effect called gravity darkening. Imagine spinning a soft ball at high speed. The centrifugal force flattens it at the poles and bulges it at the equator. The same happens to KELT 9. Its poles compress closer to the core and become hotter, while the equator bulges outward and becomes cooler. The temperature difference can reach 800 degrees Celsius. What does this mean for KELT 9b? Its orbit doesn't lie along the star's equator like planets in our solar system. Instead, it passes over the star's blazing poles. This means that in its tiny year, only 36 hours, KELT 9b passes through cooler equatorial light, then scorching polar radiation, experiencing 2 summers and 2 winters of hell in just 1.5 Earth days, each season lasting only about 9 hours. A superhot star spinning at insane speeds paired with a planet on a polar orbit. Together, they create one of the most extreme environments ever discovered. KELT 9 is a cosmic forge, and KELT 9b is the victim being melted inside it. In cosmic real estate, distance is everything, and KELT 9b got the worst deal possible. Its orbit isn't just close, it's absurdly, catastrophically close. Earth orbits the Sun at 150 million kilometers. What about KELT 9b? It orbits its star at just 5 million kilometers, 30 times closer than Earth is to the Sun. If the Sun were a basketball, Earth would be 26 meters away. Mercury would be 10 meters away. But KELT 9b? It would be just 85 centimeters from the basketball, practically brushing against the star. As a result, 1 year on KELT 9b lasts only 36 hours. The planet hurtles through space, receiving 44,000 times the radiation Earth receives from the Sun. It is a continuous storm of energy. And once a planet gets this close to its star, one fate is inevitable: tidal locking. Our moon is tidally locked to Earth, which is why we always see the same side. Earth's gravity slowed the moon's rotation until it synced with its orbit. The same happened to KELT 9b, but in an even more violent way. The intense gravity of KELT 9 has forced the planet to always show the same face to the star. This creates 2 completely different worlds. One side is the eternal day side, a non-stop inferno, blasted by 10,000 degrees Celsius radiation, reaching over 4,300 degrees Celsius. The other side is the eternal night, a world of endless darkness. Even without direct light, it is still extremely hot.
meaning some powerful mechanism is transporting heat efficiently from day to night. That mechanism is one of KELT-9b's strangest features, a direct result of its extreme temperature. The boundary between the sides, the twilight zone, may host the most violent weather in the universe, with supersonic winds whipping around the planet at tens of kilometers per second. This hellish whirlpool isn't just an orbit, it's a slow-motion death sentence.
If there's any place where normal chemistry breaks down entirely, it's the atmosphere of KELT-9b. It isn't a blanket of gas, it's a boiling plasma soup, a colossal chemical reactor. Hydrogen molecule dissociation. On Jupiter, hydrogen exists mostly as H2 molecules, but on KELT-9b's scorching day side, 4,300 degrees Celsius is hot enough to rip these molecules apart into individual hydrogen atoms, H. Essentially, the planet is melting its own atmospheric molecules. But the story gets even stranger. These free hydrogen atoms are blown to the cooler night side. There, temperatures drop enough for them to recombine into H2 molecules, releasing heat into the night. Then, the winds carry the molecules back to the day side, where they're ripped apart again. This dissociation recombination cycle acts as a massive heat transport system, explaining why the night side isn't frozen solid. It's planetary-scale air conditioning, but violently extreme. Evaporated metal clouds. As if disintegrating molecules weren't terrifying enough, KELT-9b's atmosphere also contains metals in gas form. On Earth, you need nearly 2,900 degrees Celsius to vaporize iron. On KELT-9b, the day side blasts past that easily. As a result, heavy metals like iron Fe and titanium Ti vaporize and mix into the atmosphere. Imagine skies filled not with water clouds, but glowing clouds of metal vapor. Detecting these metals in the atmosphere was one of the most spectacular discoveries about this planet. Scientists even found traces of rare heavy metals, elements rarely seen in a planet's atmosphere. On the cooler night side, these metals may condense and fall as molten iron rain, only to be swept back to the day side and vaporized again. It's a cycle straight out of hell. Superstorm weather. The enormous temperature and pressure differences create winds of unimaginable speed, possibly supersonic blasts whipping around the planet at tens of kilometers per second. One of the biggest mysteries is the hotspot shift. Logically, the hottest point should be directly under the star, but observations show it's shifted eastward. Normally, winds cause this, but on KELT-9b, the violent hydrogen dissociation cycle may overpower the wind effects. This mystery shows how much we still don't understand about this chaotic world. The relationship between KELT-9b and its star isn't just torture. It's annihilation. The planet is being eaten alive. This process, called photochemical evaporation, is happening on a scale never seen before. The star's intense ultraviolet radiation bombards the atmosphere, giving energy to gas particles. In the planet's upper atmosphere, gravity is weak. With enough energy, particles reach escape velocity and flee into space. KELT-9 is literally blowing KELT-9b apart, just like the sun blows the tail of a comet. Scientists estimate KELT-9b loses between 100,000 and 10 billion kilograms of atmosphere every second. That's like evaporating the entire mass of the Great Pyramid of Giza in just a few minutes. KELT-9b may even trail a massive comet-like tail, its own atmosphere streaming into space.
what future awaits Kelt 9b? If it's pure gas, it may eventually evaporate completely. But if it has a rocky or metallic core, the gas layers will peel away, leaving behind a scorched, Earth-sized core, a hellish version of Mercury. But even that isn't the end. Stars like KELT 9 live fast and die young. In a few 100 million years, it will swell into a red giant and swallow KELT 9b entirely. No matter what, the planet's fate is sealed. It is evaporating day by day and will eventually be consumed by its own star. KELT 9b is a fleeting moment in cosmic history, a monument to nature's ability to create and destroy unimaginably extreme worlds.
And that brings us back from KELT 9b, a hellworld with 36-hour years, an atmosphere where metals vaporize, and a planet slowly being devoured by its star. Kelt 9b isn't just a cosmic horror story. It's a profound reminder that human imagination can barely grasp the strangeness of reality. It challenges our knowledge and forces us to ask new questions. When we look up at the night sky, among billions of stars, countless worlds like KELT 9b may be waiting to be discovered. Every tiny dot of light holds a story. The discovery of KELT 9b is a small step, but an important one. Proof that the universe still hides wonders and terrors beyond anything we've imagined. What do you think about KELT 9b? Do you believe even more extreme planets could exist? Share your thoughts in the comments below. If you enjoyed this video, don't forget to subscribe and turn on notifications so you can join us on more journeys to the strangest corners of the universe. Your support means the world. Thank you for watching, and see you in the next cosmic adventure.